Welcome back to Boson Buzz. I'm Monty Molecule. Look up at the night sky. Between the ancient, steady stars, a new kind of constellation is now moving, not made of burning gas, but of polished metal and silicon. Thousands of small satellites are being launched into a shell around our planet, not just to beam the internet to your phone, but to perform a far more profound task. For all of human history, our world has been mostly dark to us in real time. We could see a storm on a weather map or find a ship lost at sea, but we couldn't feel the planet's pulse as it happened. What if we could give the Earth a digital nervous system? A layer of intelligence that lets us sense changes across the entire globe, instantly, connecting the most remote mountain village to the heart of the modern world? This is the story of the Skynet, not a trap, but a lifeline, woven from the heavens themselves. To understand the revolution, we must first understand the problem of distance and darkness. Imagine a cargo ship crossing the vast, empty stretches of the Pacific. For days, it's a tiny dot in an ocean of blue, out of sight of land and often out of range of traditional communication towers. If it gets into trouble, it can vanish, and search teams have an entire ocean to scour. Now, imagine a farmer in a remote valley whose crops are threatened by a strange blight. She needs advice from an expert hundreds of miles away, but has no internet to send a picture. Or picture a team of scientists trying to track the health of the Amazon rainforest, relying on a few expensive, slow satellite passes every few days. In our connected cities, we live in a world of instant information. But for huge swaths of the planet and crucial global systems, we've been living in the dark ages. The old solution was giant satellites, the size of school buses, parked incredibly high up in what's called geostationary orbit. From there, one satellite can see a third of the planet, but it's far away, over 35,000 kilometers. So signals are weak and slow, like a faint whisper from a mountaintop. The new idea is brilliantly simple. Go lower and use many, many more satellites. This is the low Earth orbit, or LEO, swarm. Instead of a few giants on distant hills, imagine thousands of bright messengers whizzing around the Earth just a few hundred kilometers up, like a super-fast highway of data right above the clouds. Each of these satellites is relatively small, about the size of a table. They are launched in batches, dozens at a time, until they form a vast interconnected mesh. Their low altitude is their superpower. Because they are so close, their signal is strong and fast. But because the Earth is turning beneath them, a single satellite can only see a small area for a few minutes before it flies over the horizon. This is where the swarm intelligence comes in. They are arranged in precise orbital shells, like layers of a grand rotating hive. As one satellite dips below your horizon, the next one is already rising to take its place, handing off your connection seamlessly. From the ground, it feels like you're under a constant, unbreakable canopy of connectivity. It's like having a relay team of Olympic sprinters passing a baton around the world, instead of one person trying to shout across a continent. This constant connection is the first, most visible gift of the Skynet: global, affordable internet. It can connect a school in the Arctic, a clinic in the Sahara, and a research vessel in the Southern Ocean with the same high-speed access you have in a city. It democratizes information, opportunity, and education. But this is just the beginning. The true transformation is turning this communication web into a sensing web. Each satellite can be equipped with more than just a communication dish. It can carry eyes that see in many types of light, ears that listen for radio signals, and sensors that measure the faintest environmental changes. This turns the swarm into a real-time health monitor for the planet. Satellites with special thermal sensors can detect the heat signature of a wildfire within minutes of it igniting, even in a remote forest, and instantly alert fire services. Radio receivers can pick up distress beacons from planes or ships anywhere on Earth, cutting search times from days to hours, but the sensing goes even deeper. By analyzing the signals sent between the satellites themselves, scientists can detect tiny changes in the Earth's gravity field, which can signal underground water loss or the movement of magma beneath a volcano. The Skynet begins to feel the planet's heartbeat. The applications are as vast as the world it watches. For climate science, it's a game changer. A constellation can measure the height of every ocean wave, the thickness of polar ice to the centimeter, and the moisture in soil across entire continents, daily. This gives us an unprecedentedly clear picture of how our planet is changing. For agriculture, a farmer can get a daily report on the health of every single field, with sensors detecting water stress or disease invisible to the naked eye, allowing for precise, life-saving intervention. For disaster response, when an earthquake or flood hits, the network can not only provide comms when cell towers are down, but instantly generate detailed before and after maps, showing rescuers exactly where the worst damage is and which roads are still open. We are moving from a world where we observe our planet in snapshots to one where we can sense it in a continuous living stream. The Skynet promises a future where no ship is ever truly lost, where no natural disaster strikes without warning, where every child has a window to global knowledge, and where we can manage the health of our forests, farms, and oceans with the care of a gardener tending a beloved plot. It is a testament to human ingenuity. We are building a ring of intelligence around our world to better understand, protect, and connect every part of it. The Skynet doesn't enclose us, it enlightens us, weaving a blanket of safety and knowledge for the entire planet. From silent oceans to connected classrooms, from unseen environmental shifts to crystal-clear global maps. That is the all-seeing promise of the Skynet. It transforms our relationship with distance and darkness, wrapping the world in a layer of shared awareness and opportunity. It's a future where the planet itself becomes more intelligible, manageable, and united. If the vision of a connected, sensed, and safer Earth fills you with wonder, please help Boson Buzz keep scanning the horizon. Give this video a like and subscribe for more stories of global innovation. I'm Monty Molecule. Until next time, have a safe and curious week.